Welcome or welcome back at C Square. In this lesson we're going to talk how to divide a segment in a specific ratio, or you may hear how we partition a segment in a ratio. In this case I said here this segment AB is divided in a 2:3 ratio. Hard to see it here. However, if you take a look down here you can see what I meant. You see this point C here is two parts away, two congruent parts away from point A, and is three congruent parts away from B. That means is in this ratio of 2:3. Okay, the key thing is to divide the segment in 5 parts, and you will see that in my first example where I go on the number line and I have 2 points M and M is at -3 and it's at 7. I need to do this partitioning, this dividing in a ratio of 3:2. And first thing I'm gonna do, I'm gonna count how far away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some of you may say, hey, I can do that. 7 minus -3, and that is 10. That's another way to do it. If you get that 10, the next thing you want to do is to divide by, again, remember the partitioning, it's 3, 2, 2. You want to divide it in 3 plus 2, which is 5. Always add these two numbers. And I'm going to divide by 5, like I said, and that will be 2. What's the meaning now? That means every 2 units I'm going to plot a point. What do I mean by that? 1, 2, I'm going to plot a point. 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 And if you notice 1, 2, I'm going back to N. So right now you can see this segment MN is divided, and I need that point, sorry. I need those points. Let me erase first. I need those points, right? So one more time, let me put them back now. Here, 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 and here. I need these points, and now we can see we have 5 pieces, 5 congruent pieces. Let me be sure. I'm looking for one that is 3 segments from M. We start from M always, right? So that will be 1, 2, 3. This is the point P. That is the answer. P is located at 3. That's it. A very similar approach you can do for this problem where we have a coordinate grid. We have segment MN and we need to partition in a 3:2. Look at here. My first thing here is to do this triangle. Probably you remember this triangle from some other classes. It's for example, we use this triangle for the slope also. But let's count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one is 10 units, right? So now what do we need to do? Okay, that 10 you see there, we're gonna divide it by 3 plus 2, which is 5. The same like the previous problem, so I kind of did an easy example here, right? So again, now we're gonna get that 2, and we're gonna move from point M to 2, 2, 2, 2. If you notice, now we have 5 pieces here on this horizontal line. 1, 2, 3, 4, 5. So which one is the point that is 3 segments, 3 congruent segments away from M? 1, 2, 3. This is the point P. How is called? In fact, let me not call it P because it's not really P, but this is the point we're looking for. And I'm gonna go up here, and this is the point P. So a good way to get the point P using this horizontal change from point M to point N. Okay, so P is located at 3 and 4. pretty much done. Let me just check if that is correct, and you can do that for n, right? So this one I have 1, 2, 3, 4, 5. We have just 5 units. And let me change it in a green. This is just 5 units. Okay, so 5 units. Now, do you remember what we did? We did this segment, in this case 5, divided by this 5, and we get 1. So that means from the corresponding point on point M, this one, I'm going to move 1 unit and plot these points. If you notice, I have 1, 2, 3, 4, 5 congruent segments. I'm going to move 3 away from this point corresponding to M. 1, 2, 3. I'm sorry, 1, 2, 3, and you notice I get in the same position, okay? But you don't have to do it twice, you get the same answer. I said here, not all the time, however, the graphical method will work, because the numbers are not friendly. So you have two choices, you have two options. Option 1 here, and option 2. Okay, and let's take a look how these two options work. We have here n, xm. Do you see how that goes? The n goes with x sub m and the m goes with xn, and that's the thing you want to remember. In this case, you want to start from the beginning of the segment, the first point in the segment. In this case is m. And then be sure here, oops, this is going to be xn over xm minus xm, the other way. Okay, and let's see how this works. Okay, so I'm going to start with this example, and you notice we have the same segment. Mn is a little bit shorter than the other one. You can try to count. We're going to have to partition in the same ratio 3 to 2 like we did before. And first of all, let's kind of I'm going to go with option 1, which, if you remember, said xp, right? Xp equals what? You may want to write this formula several times to remember. Nxm, or sub n to be correct, plus mx sub n over n plus m. And for a while you may want to write the things on the right in this case. And let's start with x sub m. What is the x coordinate of point m? Negative 3. X coordinate of point n is 5. Then we have 3, 2, 2. So that means m is 3 and n is 2, right? So let's see how that works here. We're gonna plug it in, and we have n, which is 2, times x sub m, that is negative 3. We really need parentheses here, right? Plus m is 3, and we don't really need parentheses here, but let's put it just to show how we plug that x coordinate of point n. And here we have 2 plus 3. Okay, so what are we gonna have here? 2 times negative 3 is negative 6 plus 15 over 2 plus 3 is 5, and that will be 9 over 5, which is a good answer. Right, so the x coordinate of point P as a fraction, which is fine, is 9 over 5. We cannot simplify. Well, let's do a simplified form. 9 divided by 5, it's 1.8. If you need a calculator, grab it and do it. This is the answer somewhere here. You see, it's hard, or almost impossible to get that point P graphically. The formula is very good. And I use the option 1. Option 2 works very similar. Just be careful how you handle those formula. Okay, and this is for the coordinate grid, or one more time, be careful. You start with the endpoint and then the endpoint, endpoint, and then endpoint. I apologize for this. And let's see. And in fact, in this example, I'm gonna use the option 2. Let me write that here. Option 2. I want you to see that works fine. Okay, we have x coordinate of point P equal. We start with the endpoint because that's the first one, plus if you remember, it's very important, start with m first, m over n plus m. And here, very important, you start with the second point, in this case n minus xm. And now let's put them in. If you need to label and identify, go ahead. And we have xm, which is the x coordinate of this point m, which is, if you notice, -3. Let me show you that here. Plus m over n plus n. So that will be 1 over n plus m, that will be 1 plus 4. Okay, let me just put that here because probably we need that. 1 to 4 is the ratio. This is m, this is n. M is 1, n is 4. And now here, be careful, you start with the endpoint. The x coordinate is 7 minus -3. So we end up here with -3 plus 1 over 1 plus 4, 1 over 5. 7 minus 3, that is +10. Now we can simplify here, or we will simply multiply 1/5 times 10, that will be +2, right? Or you can do this if you want. And the answer will be -1. The x coordinate of the point P is at -1. That's good enough. Look at here. This is -1, right? -1. Go down, 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 down. This is the point. This is the point P. Okay. Now let's do something similar for the y coordinate of point P to see if we are correct. The y coordinate of point P, the same formula, right? We're gonna start with ym plus m over n plus m. And remember, you want to start with the y coordinate. Do not start with the m coordinate like I put it originally. Okay, so what do we get here? We're gonna have ym, y sub m, that is this guy, -3, right? Plus 1 over 1 plus 4. And then yn, so this is the point, we have +3 minus -3, the one we start from. So, and I'm sorry, this is 1 plus 4, not plus 5. So we have here -3 plus 1 over 5, and 3 minus -3, that's 6. So we have -3 plus 6 over 5, which you can change it in a decimal if you want. Okay. Or -3 is -15 10 over 5 plus 6 over 5. That will be y sub p will be negative 15 plus 6 is negative 9 over 5, which is good, or negative 1.8 if you want this decimal thing. Okay, well, let me see, is that a good one? I think we're good, right? You notice that point goes of that. Okay, so the P is located at negative 3 and negative 1.8. Okay, so very important on this option 2 to remember m goes first here, xn goes first, and then this difference you start with the second point. Okay, let's move on. So on this next thing, I said sometimes the partition is given to you and you have to determine the ratio of different segments. So use the figure below where point P, in fact, is located at negative 1 and 8/5. So let's see what that point is, negative 1 and 8/5. So that's good. That negative 1 really help us. It's right here. Okay, that is point P. Okay, and we need to find the ratio of MP by Pn. Okay, we need to find that one. Okay, so the easiest way is to pick your fight, and the fight will be a graphical approach. You remember this triangle? We use it. I'm gonna use it one more time. Okay, because that's the easier way to go. And I'm gonna go and get the corresponding points for point P right here, right? I think it's pretty easy. Let me call it P prime. If you never heard about that, that's the P prime. Now you want to take a look to that P prime and see how far away it's from M prime. Let's call it like that. And this one, if you want to call it N prime, that's fine, but it's the same thing like N. And let's count now. 1, 2, 3, 4. This is 4 units. 1, 2, 3, 4, 5, 6. This is 6 units. So MP over Pn is going to be this 4, right? MP goes with that 4 over Pn, which goes with 6. Now, can we reduce this fraction? The answer is yes. The answer will be 2 over 3. And you see how easy it is to do it graphically. Part B, we need to find the ratio MP over Mn. And again, we're going to use the graphical approach. MP, this MP goes with this corresponding segment, which is 4. And Mn goes with what? This will be the corresponding guy. How long is this guy? 4 plus 6, right? That would be 10. 4 over 10 means 2 over 5. That's it for this problem. Very easy if you want to use the graphical approach. Let's take a look to this example. Point C, D, and E are collinear. Point C is located at negative. I'm sorry, D is. These points are collinear on CD, on C, and CD over D is 3, 4. C is located at negative 2 and 6. D is located at 1 and 0, and E is located at xy. What are the value of xy? So again, graph paper, let's try to use a graphical approach. And one more time, let's take a look. C is located at negative 2 and 6. So I'm gonna go 2 left, 6 down. This is point C. Let's in fact -2 and +6. So let's redo it, -2 and +6. This is point C. Let's label. D is located 1 and 0. That means right here on the x-axis. And E we need to find out. And we know C. So again, this is D. We know CD over DE is 3/4. So a ruler, that will be good. And we have CD over DE, it's 3/4. So what I want to do here, and probably that is better, let me erase this, is to break this segment CD in 3 parts. Okay, in these 3. Okay, so 1, 2, 3, 4, 5, 6. You notice this is 6. That means I'm gonna go 2 down, 1 right, 2 down, 1 right, 2 down and 1 right. And you notice I'm doing a good job, a very good job in fact. Okay, and you notice it is. So this was 2, 2, and 2. This was 1, 1. At the same type of pattern we move it, right? Now I'm gonna do the same thing from point D. I'm gonna move 2 and 1, 2 and 1, 2 and 1. How many times? You're gonna move 4 times. Let's see, do we move 4 times? 1, 2, oops. No, we need to move 1 more time. 2 and 1. So I'm gonna move 2 and 1. This is where point E is located. Okay, now I can really connect, hopefully doing a decent job. Use a ruler, by the way. This is E. This is point E, which is located at 5 and -8. Don't have to do any algebraic way, just the graphical way will work fine in this case. Hopefully you don't get anything super complicated where you have to do a lot of algebra. Okay, now let's take a look to the next example, very similar. We have now JK is in the coordinate plane, has the points with coordinates -4 and 11. -4 and 11. I think that would be right here. Okay, let's label the point. I say this is J and K 8 and -1. Right here, a pretty long segment. I don't even dare to connect it because on the screen I'm gonna miss it. Find the 2 points, 2 possible locations for point M. So divide JK in 2 parts with lengths in a ratio 1 to 3. So again, 1, 2, 3, right? We're gonna have to have how many segments? Oops, 1, 2, 3. We're gonna have to have how many segments? Let me erase these equals. We have to have 4 segments. Okay, so again you can count and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Am I right? 12. 12 divided by 4 is 3. That will tell me you go 3 down, right? Let's count the exchange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 also. Oh, another 3. So I'm gonna go 3 down and 3 right. 3 down, 3 right. Hopefully we do a good job. We'll see it at the end. 3 down, so 3 and 3. And 3 right, the second segment, 3 down, 3 right, and now we'll see it if we did a good job. 3 down, Yeah, we did a good job. We are back to K, and we're lucky this problem can be worked graphically. Now, if you want, I can try to get the segment. It's easier. Of course, you may want to use a ruler on your graph paper. But this is now the segment JK, and you see 1, 2, 3, 4. 4 congruent parts, the one we're looking for. Now we're looking for point M. Okay, and we have two choices. One will be here, which is -1 and 8. And what will be the other one? Okay, because you see here it's kind of give you the other choice. That will be this guy. So let me call this M1, the first choice, M2, the second choice. So in this case you have these two choices. So this is going to be 5 and 2. Now if you ask me, that the first one will divide the JK in a ratio 1 to 3, because I start from J and go to K. The other one, I will call it KJ, and that would be a good way to see it for the point M2. Part B, on the same thing. If you remember, suppose JP, JK, JP and K are collinear. On JK, we need to find the segment that is 1, 2, 3. Okay, so again, I'm gonna use this slide very fast. We already did this work, so I'm gonna move a little bit faster. J, K, hopefully I'm not gonna miss it. If you remember, we did it 3 and 3. 3 and 3. Hopefully you have it on your graph paper. 3 and 3 already, and 3 and 3. These are the points, right? And now we need to find JP over JK is 1 over 3. Okay, so that we have a problem here. Okay, so let me just try to do the segment, since we did that. Okay, so JP over JK. So very important, this is 1 over 3. This is a different problem, ladies and gentlemen. Okay, because now JP is 1 segment, JK is 3 segments. So 3 corresponding parts. So let me erase these points. I erased the line also. Yeah, that's the problem sometime. So again, let me, hopefully we did a great job. So what you really want to do here, pick one of these guys, again the graphical way. And if you remember, this is 12. Okay, so I'm gonna put that 12 here. That 12 shows us the corresponding piece for JK, right? What will be the corresponding piece for JP? What divided by 12 is 1 over 3, and that will be 3 times 4, it's 12, so 1 times 4 is going to be 4. This is the 4 we're looking for. 1, 2, 3, 4. This is the point, right? So one more time. 1, 2, 3, 4. This is the point P. Okay. So I can do that one more time. 1, 2, 3, 4. This is going to be. And you notice now we have 3 pieces. This is 1, 2, 3. So the point P is located at 0 and 7. Very important to read the problem. Sometimes they can be tricky. Okay. So sounds similar, however different, and be careful of that. Okay. And the last problem in this lesson, we have a direct line segment. I think I mentioned that this, but now you can really see it. That tells you you start from a -3 and 1, which is right here. Z 3 and 4. Okay, so you see I put the points down on the paper. Now we have points 1 and 2 for L. I think I have a problem here. Let me see. We'll see it in a moment. -3 and 1, 3 and 4, 1 and 2. I can see a problem. 0 and 5/2. That will be right here. Okay. The whole idea here is let's do that segment AZ. I think that will be good. Okay, so I think you may want to change this one in 1 and 3, I guess. 1, 2, 3, 4, 1. Okay. So this is the point M. This is the point L. I apologize for that mistake. And now I think we can answer to these parts. All these points are collinear. Okay, very important to remember that. So now find the point that partitions AZ in a ratio 1:1. Which one looks as one segment? What points divide the segment AZ? One part away from A and one part away from Z. That will be point M, right? So this one, okay, let me erase. This one, that is one away from A, one away from Z, one part. That is point M, which is, if you remember, 0 and 5/2. Now let's take a look to part B. Find the point that partition AZ in 1, 2, 2. 1, 2, 2. So 1 away from A, 2 away from Z. Do you see? This is the point. 1, 2, 3 segments, right? 1 plus 2 is 3. Okay, so let's call this one point P, which is -1 and 2. Okay, this was not given to us, but now we have it. And guess what is point L, the last one? It's, let me change the color. The same segment in a ratio 2:1. That will be 1, 1, 2, and 1. So that is point L, which is, be careful, I have a mistake here. It was 1 and 3. And that's it for all this lesson today. I hope you enjoy, and give me a like and come back on C-Square for more help. Thank you.